I'm going to present different topics, including synchronous circuit, flip-flops, and their applications, and also sequential circuits. And first, I will explain the synchronous circuit. This circuit is a sequential circuit in which the feedback to the input for next output generation is covered by clock signals. The input is in a form of a pulse, therefore, synchronous circuits are divided into clock and unclocked mode, or what we call also a pulse mode. Synchronous circuit is part of a sequential circuit, and its counterpart is the asynchronous circuit. And under the synchronous circuit, we have the two types, which are the clock sequential circuit and the pulse sequential circuit. As you can see, we have three input levels and also three output pulses or levels. An output pulse only occurs for the duration of the input or the clock pulse. On the other hand, the level output change its state at the start and remain until the next state of the output. So this is the clock sequential circuit, and they are very stable, and the memory element used in the circuit is called a flip-flop. However, it is slower in operation of speed because of the propagation delay of this clock signal. The next type of a synchronous circuit is the post-sequential circuit, where the input is in the form of pulses and the output is either output pulse or levels. These circuits change their state using the pulse. Overall, synchronous circuits are always predictable, thus reliable. They are usually used in counters, shift registers, or memory units. Now let's go to the flip-flop and its equivalent logic circuit. The first type of flip-flop is our SR flip-flop, and this is the schematic or the symbol for this flip-flop, and this is the equivalent logic circuit. This circuit is called the gated SR flip-flop, while this portion is what we call the basic SR flip-flop without the clock. This SR flip-flop is can be cross-coupled with NAND gates or NOR gates. NOR gates SR flip-flop are active high, meaning if the set if the set is 1, the light bulb will be turned on, and it will not turn off until the reset button is high. So this S right here corresponds or represents as the set, and the R is for the reset, and the outputs are the Q and the complement of the first output. So this Q output will remain until the reset button is applied. And the next one is the active low SR flip-flop, where instead of these two NOR gates, it will be replaced with NAND gates. So when the set is 0, the Q will be high, and then it will not change, or it will remain in logic 1 until the reset button will become active 0. So that is the SR flip-flop. This flip-flop is also important because all other types of flip-flop are built from this. So, and this is the truth table for the basic SR flip-flop. The output Q will remain 0 until the set input is 1. So if set value is 0, it will always have an output of 0, and the other output is the complement of that, which means it will become 1. And when the set is high, the first output Q should be also equal to 1. And then the complement of that for the other output is 0. And the first output Q will become 0 if the reset button is high. And the complement for that is 0. The second type of flip-flop is the D flip-flop, and it has a symbol or schematic of this and an equivalent logic circuit with this. The only input is the data pin, or labeled as D, and the output is the same with the SR, the Q, and the complement of Q. This flip-flop is made from the basic SR right here and added with two AND gates. And the traditional D flip-flop has an inverter, and there are other circuits that don't include an inverter. This added inverter is to make sure that the input here and here are always with complement to each other to avoid invalid outputs. So the output Q is always the same with the input D. If this is 0, so the other input should be 1 because the inverter, and the Q is equal to 0. And if it is 1, the other input is 0, and the output Q is 1, and the complement of this is 0 to the output of Q bar. And that's it for the D flip-flop. This third type is the JK flip-flop, and again it is made with a basic SR flip-flop with two NOR gates, and it is an improved version of the SR where the output of Q is directed to the input of K, making this AND gate a 3 input, and the Q bar is also directed to the input of J, also making this a 3 input AND gate. And if the input are 1, 1, and 1, it will serve as a toggle flip-flop where it stores a memory. That's why JK flip-flop, sometimes called a toggle flip-flop. The last type for the flip-flop is the T flip-flop or the toggle flip-flop. And this is the schematic symbol, and this is the equivalent logic circuit. This type of flip-flop is really not available commercially, but it can be made from the other types of flip-flop such as the JK flip-flop conversion and the D-type flip-flop conversion. In the JK flip-flop conversion, using the JK flip-flop, the J and K inputs are just have an input of 1. And in the D-type flip-flop version, the Q bar, this is the Q bar, will be directed to the input D in the D flip-flop. So when this is directed to the D input, the corresponding clock is now the input also. And that is for the T or toggle flip-flop. The applications of flip-flop are for counters, shift registers, storage registers, data storage, latch, data transfer, bounce elimination switch. And the applications of sequential circuits are shift registers, flip-flops, analog to digital and digital to analog converters, counters, clocks, used to build the memory unit, and as programmable devices, such as programmable logic device and complex programmable logic device. And that's it for the presentation.